Welcome to right triangle trigonometry. I have here two identical right triangles. I've of course labeled the hypotenuse as being the side which is across from the right angle, and we know that the other two sides are known as the legs. Well, what we're going to do in this discussion is we're going to identify one of the two remaining acute angles. And I'm going to label the one I pick as theta. Now I'm going to pick the lower right hand angle here as theta. I of course could have picked the angle up on top. I'll do that in a later example. Once though we have chosen the angle theta, we're then going to label our two remaining sides using the words opposite or adjacent. Now they're pretty easy to understand. You figure if you're at theta and you look opposite on the triangle, that's therefore known as the opposite side. I'm just going to abbreviate that OPP for opposite. The remaining side then is known as the adjacent. Notice the hypotenuse is never controversial. It's always fixed. It's right where the right across from where the right angle is. Now on the example to the right, let's just see what would happen if instead I decided to focus my attention on the upper angle, theta. If we're looking at that angle, then notice the opposite ends up being down here on the bottom, and now it's the adjacent, which is over here on the side. So part of the trick in doing right triangle trigonometry is focusing your attention on an angle and then appropriately labeling the three sides opposite, adjacent, and hypotenuse. We'll look at the first of what will turn out to be 6 trig functions. The sine function, abbreviated SIN, will be done in the following way. Well, let's first go and choose an angle theta. I'm going to choose the one down here. You know, I could have chosen the one on top. Now once I have chosen that as my angle in question, angle of interest you might say, then the side across from it too is the opposite. It's a side opposite that theta. Notice the hypotenuse always is a side across from the right angle, and therefore we're left with the side adjacent to our angle. Now here is a definition for the sine of theta. The sine of theta equals the opposite over the hypotenuse. This is something that you'll definitely want to remember. And let's do it using the numerical information that I supplied. All right, the opposite side we see is 2, and the hypotenuse is square root of 5. We'll of course rationalize the denominator. We would multiply the numerator and the denominator by that square root of 5, which is in the denominator. It gives us 2 square root of 5, and the bottom would just be 5. So when we rationalize the denominator, it means essentially we're getting rid of the radical symbol in the denominator. And that's the sine. The second one is the cosine. Well, just to be consistent with the last example, I'll pick the same angle, lower right, to be theta. So this problem will be labeled just the way the previous one was. And now for the definition. The cosine of theta is defined to be the adjacent over the hypotenuse. All right, now let's just take our numbers and plug them in. Our adjacent, look at the triangle, is 1, and the hypotenuse is square root of 5. So just like the previous problem, you can rationalize the denominator. It would be the square root of 5 over 5. There we are. And now for the third function, the tangent function, abbreviated TAN. Let's just for now let these things be the same. So again, a side across from the right angle is the hypotenuse. The side across from the angle is the opposite, and finally adjacent. And here's your definition. Tangent equals the opposite over the adjacent. Well, what will that be for this problem? The opposite is 2, the adjacent is 1, and 2 over 1 would just be 2. So the tangent of theta equals 2. Before I show you the other 3 trig functions, let me show you an easy way of remembering the rules for the first 3. It's a silly little nonsense phrase that students have been learning for decades, oh, who knows, maybe 100 years. SOHCAHTOA. Here's what it refers to. The first letters SOH, so, tell you that the sine is the opposite over the hypotenuse. Notice SOH. CA, CAH, adjacent over hypotenuse. And finally, tangent, TOA. Tangent equals opposite over adjacent. I've heard some kind of humorous phrases some people have used to remember these. You know, ask around, ask your teachers if they know any. But SOHCAHTOA works just fine. I found that people have no problem remembering those. Now for the last of the 6 trig functions. They're really reciprocal trig functions. They're just reciprocals of the ones that I showed you previously. First, the cosecant, notice the abbreviation CSC. It's the reciprocal of the sine. Meaning if you know what the sine is, you just invert it. Take the reciprocal and you'll have the cosecant. Secant equals 1 over the cosine. Look at the abbreviation. And cotangent equals the reciprocal of the tangent. So let's put all these ideas together into one nice example. I've given you a right triangle, and we're going to find the 6 trig functions for angle theta. Well, I haven't labeled theta yet, and my thought was, just for variety, let's do the angle up here in the upper corner. We haven't done that in an example yet. Well, once I've labeled that angle theta, notice the side opposite of that angle is where the 2 is. So 2 is our opposite. 3 is our adjacent. Why is that the adjacent? Well, because you know that that diagonal side across from the right angle is the hypotenuse. Now, of course, I'm sure you also notice that I have not given you a number for the hypotenuse. So we might as well go do that before we worry about anything else. We will use the Pythagorean theorem in order to come up with the hypotenuse. We know that a squared plus b squared equals c squared, and in the Pythagorean theorem, c is always the hypotenuse. A and b are just the legs, and therefore we would have 3 squared plus 2 squared, or vice versa, equals c squared. 9 plus 4 equals c squared. 13 equals c squared. And finally take your square root on both sides, and you'll have c equals the square root of 13. Normally in algebra, you'd say plus or minus square root of 13, but the side of a triangle can't be negative, so we'll just deal with the positive here. Now, let's use our definitions to come up with the 6 trig functions. Let's use SOHCAHTOA first. Oh, by the way, I might as well go and put that number we got here and put it on the triangle, make it convenient for us. Hypotenuse there. All right, now back to what I was saying. SOHCAHTOA. Sine of theta equals, so is opposite over hypotenuse, so that would be 2 over the square root of 13. I guess we better rationalize that by multiplying numerator and denominator by the square root of 13. And we'll have 2 square root of 13 over 13. Cosine equals adjacent over hypotenuse. Again, Easy enough to rationalize the denominator. And then tangent of theta. Tangent is opposite TOA. Remember TOA, it's opposite over adjacent. We got those pretty quickly. We're going to get the last three even quicker. Recall that the cosecant equals the reciprocal of the sine. So we have to invert or take the reciprocal of the sine. Well, I would not recommend that we invert our final answer. I'd recommend that we invert this, because notice if we invert that, we'll have the square root of 13 over 2, and we won't have to worry about rationalizing the denominator. We're good. All right, then the secant is the reciprocal of the cosine, so let's flip over this first version here. Square root of 13 over 3. And then the cotangent is just the reciprocal of the tangent. 2/3 becomes 3/2. Hope you found that helpful. Tune in again.